All right, so let's take a look at this review guide. Now, you notice we have no calculator part in it, calculator part. So let's just go ahead and start solving these things. So first type problem, just solve. Okay, now notice it is an inequality there. So I'm going to rewrite the whole thing. Always good practice to help you recognize what's going on. See, we'll get our x's on the same side. I'll just move them to the left, giving me 4 minus 7x is greater than negative 17. I'm going to subtract 4 from both sides, giving me negative 7x is greater than negative 21. So I subtracted 4. Last step, divide by negative 7. Now here's the thing you have to remember about inequalities. If you divide by a negative when you're solving, that inequality has to flip around to keep it true. Now negative over negative is positive, so x is less than 3. And it says graph it, so let's graph it real quick. There's a 3, and I got to be less than it. There we go. That's not too hard. 2 is the same problem. Solve and graph. We'll subtract our 20. Negative 3x is less than, let's see here, that's negative 12. This time I'm dividing by negative 3, so it'll flip it also. Greater than now, and 12 over 3 is 4. Negative over negative is positive. Greater than 4, so it looks like this. So everybody bigger than 4. 13, just an equation. Subtract 7p. Make sure I'm giving you guys a review guide, not the actual final, because the final looks just like this almost. Subtract 7p, giving me 3p plus 8 equals 14. Subtract 8. 14 minus 8 is 6, and divide by 2, or 3 to get 2. 6 over 3 is just 2. We're done. Problem 4, we got to distribute here now. So be careful. I'm going to do it underneath so you can see it there. Negative 2 times 3 is negative 6x. Negative 2 times negative 4 is positive 8. Now we'll subtract our 8. Negative 6x is less than 8. Now we divide by negative 6. Don't panic if it doesn't come out even. X is. Now we divide it by a negative, so we flip the inequality. See, 8 over 6 simplifies to 4 over 3, and I just put the negative on top. It says graph it, so we'll graph it real quick. Now negative 4 1/3 is kind of hard to find. Think of it as negative 1 1/3. So here's negative 1, here's negative 2. Negative 1 1/3 is somewhere around there. We want to be greater than it, so we'll point to the right. All right, here we've got 2 inequalities. Notice they are both in that same problem. So we have to solve both these equations. So kind of think of a line being right here. And we have to subtract 8 from both sides. So if you want to do it all in one step, it looks like this. Negative 16 is less than, let's see, we get 4x. 4 minus 8 is negative 4. Last step, divide everybody by 4. Negative 1. And there you go. Now, if you don't do it that way, you write this thing twice, like that, and you repeat the middle. And then we solve both those. But it's the same thing. It's just I think it's easier to keep track of when you do it separately. So x is greater than negative 4. And divide by negative 4, x is less than negative 1. So same answer. Regardless of how you do it. Let's see here. Graph this equation. All right. We can graph that guy. Let's see here. Y equals mx plus b. So my y-intercept is negative 6. 1, 2, 3, 4, 5, 6. So I'm on my, there it is. X or y equals negative 6 right there. My y-intercept. Then my slope is 1 over 5. Remember, that's rise and run. So it says from this point, rise 1 and then run over 5. 2, 3, 4, 5. So this would be up 1 and over 5 from it. Right there, and 2 points is enough. Draw a line. There we go. Number 7, we'll graph that one right on there with it. Let's see here. This one's got 2y, so we're going to have to divide everybody by 2, so we're in slope-intercept form. 3/2 x. And 8 over 2 is just 4. So let's do him in red so he stands out on the graph. So our y-intercept is 4. 2, 3, 4. Here's our y-axis, right? So we'll put it at 4. Trying to label that y. And that slope is 3, 2. So we go up 3, 1, 2, 3, and over 2. There. Or you can go down 3, 1, 2, 3, and back 2, like so. Just put some arrows on those lines like that. That was 7. Number 8. Ooh, identify the transformation from the graph of f to g. So we're going from f to g. F is the dashed line. So this one is f and g. And we're supposed to describe f to g. F to g. So we can see it looks like it's slid up. 2, 4, 6. Where's that 8? Let me zoom in here, see if I can tell better. No, that's it. Oh, let's see how far it slid up then. So this is up here at 5, but see, we're starting at 2. So this is 2, 4, 6. We've gone up plus 1. We've gone up by 7. Now that 7, remember our parabolas. Y equals a times x minus h squared plus k. This one's not shifted left or right, so h is just 0. That's our shifter for left and right. I don't know what a is. But we can see if I want to move it up by 7, that's what my k value has to do. Okay, it shifts it up by 7. We can clearly see that. I don't know why I'm going through all the equation stuff. You can just see it shifted up. It's not shifted down. That would be if you're going from G to F. It's not horizontally stretched. It didn't get wider on us. And it's not translated right or left. It takes care of the first page for us. Page 2. See, write the equation of the function. I've translated 6 units up. Well, we just kind of saw that. If you want it to go up, you add the 6 on the outside. So x squared plus 6. Okay, if they wanted it to shift left, for example, we'd put that on the inside. Notice we use a plus, I don't know, plus 6. That would shift it left 6. If I want it down 6, I'd do minus 6 on the end. Solve the system using elimination. You guys, several of these on here. So let's review elimination real quick. In elimination, you just want to multiply an equation by something to get the variable to disappear. Let me explain. Let's say I want to get rid of my x's. Right now, if I add those two equations, 2x plus 3x is 5x, nothing disappears. But if I multiply this entire equation times a 3, that would give me a 6x there. And then if I multiply this equation times a negative 2, it would give me a negative 6x there. And then they would add up to nothing. So I'll take my first equation times 3. I'm just tripling it. And I'll take my second equation times negative 2. So I'm doubling it and multiplying by negative. And see, this was all done so that these now, the x's, are equal and opposites. So that when I add the two equations together now, the x's disappear. So negative 9 plus 8 is negative 1y equals 17. Divide by negative 1. Y is negative 17. Now that you know y, just go back to either of these equations here and put that y is negative 17 in. I'm going to do it to the first equation. It shouldn't matter which one you put it in. In fact, it doesn't matter. But what you may want to do is put it in both to see if they agree. And assuming they do agree, then you know you're correct. So I've plugged in, I got my 2x minus 3 times my y, but my y is negative 17. So I solved this. 17 times 3 is 51. Subtract 51, that gives me negative 44, I believe. Divide by 2. So I think these two lines cross at negative 22. Oops. If I can get my eraser to work. Looks like they cross at negative 22, negative 17. Now, just for sport here, I am going to stick it in the second one, see if that agrees. So 3x minus 4 times negative 17. Again, putting in that new y value. See if that equals 2. Or if this comes out to the same thing, negative 22. So that's plus 68 equals 2. Subtract 68, I get negative 66 divided by 3, negative 22. Yeah, it agrees. So both of them go through the exact same points. Question 11 here. Use the formula negative b over 2a. We had that in class. That's to find the axis of symmetry of this parabola. Well, that's going to be easy because they already gave it to us in standard form. So we know a is 2 and b is 12. And we know c is 5, but we don't need that for this equation. So x equals the opposite of b, negative 12, over 2 times a. That's negative 12 over 4, which is x equals negative 3. There we are. Number 12 here, this is right off of the stuff we're doing currently in class. We just have to factor this. Remember, x, and we just got to figure out what r and s are here. Well, r times s has to equal your c, so negative 8. Now that gives us a list. That could be a 1 times 8, 2 times 4. Those are the only two things that multiply to 8. Now they've got to add, multiply to negative 8, but they got to add up to this negative 2 in the middle. So r plus s has to equal negative 2. Well, that's only the 2 and the 4 have that possibility. If they're going to add up to negative 2, the 4 would have to be negative. So let's check it. 2 times negative 4 is negative 8. They multiply. 2 plus negative 4 is negative 2, so they add to the correct thing. So we now know this quadratic factors is an x, and our r is 2, and our s is negative 4. So let's see here. It's not this one. It's not that one. Here we go. Minus 2, or minus 4 and plus 2. Got to be C. 13 was not true about this parabola. The x-intercepts are negative 3 and 5. Let's see here. X-axis is right down here. 1, 2, 3. It crosses at negative 3. It crosses at 5. So yeah, it does that. The y-intercept is 7. Here's our y-intercept up there. That y-intercept, here's the y-axis. It's crossing at 15, so this one's not true. See, the maximum value is 10. And that one's not true. There's 2 of them that aren't true here. The y-intercept is 7. That's false. Maximum is 10. That's false. This thing goes up to 16. The axis of symmetry x equals 1. Let's check. Yep. So that one's true, false, false, true. Next, problem number 14 here. Given function f of x equals the absolute value of x, write one that represents a vertical stretch by a factor of 4. Well, the stretch is something we talked about it a lot. In this case, we're coming up with g of x. Remember, it was a times x minus h quantity squared plus k. And we always commented how the a is what causes it to stretch or vertically shrink. Well, in this case, they want the parent function, instead of being a quadratic, is just an absolute value. So we just want to change a, in this case, to a 4 to make it stretch by that factor of 4. Let's see here. Next page. Ooh, no, last problem. This is it for the part without a calculator. So question 15, what is the parent function of negative 3x squared minus x plus 1? So it's just whether it's quadratic, linear, square root, or an absolute value. Well, we've been talking about these to death last couple of days. That is a x squared, and remember, x squareds are quadratic. And that's it for part 1.